Welcome everyone to another programming video by me. This is not much of a tutorial but more of a problem solving type of video, because when you are getting started with programming, or even if you are intermediate about it, you might always run into situations where you are just feeling like, okay, how do I even approach this problem? And I want to show you a way how I would like to approach a problem when I just try to learn a new technique in audio programming. And I will explore this by actually figuring out a new topic that I haven't implemented myself yet while recording this video, so that you can see how it actually looks like to use this approach. I always like to start by just making things really practical, and that's why we're here in the DAW and not in the IDE yet. As some of you might know, I'm currently reworking my Perlin noise modulator for my plugin Nell, so that it can have procedurally generated curves. And that makes a lot of sense, because let's say you are on a specific bar, and then you can just play back that bar in a loop, and you can see that it will take the same shape all of the time. And you can tweak the parameters to just get the modulation to be just the way you want, or you can just move the phase somewhere else in order to get a different curve for that section, which is also very useful. As you can see, the modulation between different phases is already smooth. Width parameter is smooth, so that's pretty cool as well. Octaves is smooth, everything works fine, except the rate. Rate modulations are definitely not smooth. They create a lot of discontinuities, and that makes a lot of sense, because you must imagine it a little bit like this. What part of the wave is being played for a specific part of this project is being determined by the project position times the rate, or something like that. You will see that in the code later, I guess. And you can imagine if you're switching to a different rate, then you're just ending up on a completely different part of the underlying noise sample that I have synthesized for this. And now you might ask yourself, how can I even approach that? So one of the ideas that you could have is just smoothing the transition from the last rate to the new rate. And that's definitely a way to do that. But the problem is that unless your smoothing is extremely slow, it will create a very high pitched and just noisy modulation, especially if the jump is very far. Now you're jumping from this position to this position, then you would be jump scared by this transition every time, which is not nice. There must be a different way to transition the rates. Now, and that's what I want to show you here in this video. That's already the beginning of it, because when you are approaching a problem like this, it's good when you are just thinking about it practically like this, not in a math way. You can figure out the math later. One of the ways how you would approach a non-smoothable parameter in a DAW would be by just having two instances of the plugin, each on a different rate level. So let's just say we have one instance here and another instance here, and this is the second instance, and here we have a much faster rate. Let's choose an even slower rate here. Now I can move the XY pad to go to the slow rate and also fade over to the fast rate. And as you can see, the transition is smooth because it's basically cross-fading between the two. So if we can implement something like that in a plugin, then that's great. And now we are going on with the actual code. So here I have the class, the Perlin noise class, that I'm currently just using for synthesizing this stuff. And now there are two ways how to approach this problem. One of them would be to ask yourself how you can tweak the things inside of here to just get this crossfading action going without having to make a copy of the entire class. And the other way to approach this would be to make a new class that's even more high level, and that class just has two Perlin noise objects, and then it crossfades between the two. And I will take the second approach, even though it seems a bit wasteful at first, because it's just easier to understand, and also it's not really more wasteful, because after we have figured out the most easy way, we might immediately see some ways to optimize that anyway. So let's just call this Perlin 2 in order to say that it contains two Perlin noise objects. So now the first thing that we should do is actually making sure that everything still works the same before actually implementing a new feature. So we will have a Perlin index that will always switch between 0 and 1 depending on which is the current Perlin object that is currently used. Now we will change the object that we use in the processor to Perlin 2, of course. No changes in the constructor. In prepare to play, we have to make a new prepare method for the sample rate and the block size, of course. So that's already something that we have to do. Okay, great. And then we also have to implement process block again. So in process block we see that we actually have to implement two methods now, one for setting the parameters and one for processing the samples. Alright, that should pretty much do the trick for now. We have two Perlin's objects, a Perlin index. We are preparing both Perlin objects with the prepare information, and every time we update the parameters we do that for both Perlin objects, and we are only processing the Perlin object that we're currently using, and that should give us a plugin that still performs the same thing as it did before. And we can clearly see that it works. It does the same thing as before, and it still has the same problem when doing rate changes because it's basically the same program. Now we have to find a way to describe when there is a jump. And you know, there are two different moments when there can be a jump in the phase of the procedural noise reading. And one of these cases is that the rate changes. Actually only the rate in beats. The rate in hertz doesn't have this problem. And the other case is that there is a huge jump in project position. And I would just say, let's just only care about the rate issue for now. So we have to add some parameters logic in here. We are keeping the rate beats value saved in here. We're just starting it out on 0 so that the first time, or actually on -1, so that the first time it hits this method, it immediately updates. Because in this method we are now asking if rate beats is not rate beats input argument, then first of all update it. Now we have to rethink what all this should be doing, but before doing that I will just say, and if they are the same, then we are still doing the same thing. So the rate has been changed, and that means that one of the Perlin noise objects now has a new rate and the other one should keep its old rate. So we are just saying Perlin index equals 1 minus Perlin index, because that means that if it was 0 then now it's 1, and if it was 1 then now it's 0. And now we can actually change the new Perlin noise object's parameters with a new rate value. Actually that reminds me that we should update the old Perlin noise before updating the rate beats value. So now this means before updating the Perlin index, so it's now the old Perlin noise object, we are still giving it the old rate beats value that was conserved from last time, but the new value is given to the other Perlin noise object. Now in order to use this information in our processing method, we should add a little boolean that says if we're currently crossfading or not. At the beginning we are not crossfading, but when this triggers then we are crossfading. Now as long as the rate beats change, we are crossfading. I'm just asking myself right now what would happen if we changed the rate beats while we are still crossfading. That might cause some problems that we have to address later, but it's good to have the edge cases in mind already without actually addressing them immediately, because we just want to get anything down for now. I want to focus on velocity here, but we can already start making some notes for that. Edge case, rate beats changes before crossfade ends. That's something to look out for later. And also maybe optimize set parameters, amount of function calls, because I think that maybe there is a way to just do a bit less here and then still let the loop run things. I don't know, maybe not. Okay, so now we want to start crossfading, and we need to have some sort of phase value that kind of defines how it fades from one side to the other. So let's just define a phase. I don't know yet if I want to use double for that or float, but I just have made the experience when phases are very slow, then you can get numerical instability errors when you're using float. So I like to use double for phase type of DSP processors. So phase is starting at 0 and it's always resetting to 0 whenever we are starting to crossfade. So now we have to think hard what we want this to do. We are synthesizing the Perlin noise onto the samples array that is given by the input buffer. And now we have two ways we can handle this thing. Either we make another buffer where we can just put in the other Perlin noise synthesizer's output, or we write another function that does not just synthesize the Perlin noise but just adds it to the samples. I think I like that approach a bit more. It's a bit cleaner because it uses less memory. So let's just make another function here, even though it might have a little bit of copied code in the end. But that can also be optimized. First of all, let's just copy everything that we had before and then tweak the things that are different. For example, I know that the part of the code that actually writes something to the samples is the process octaves method. So let's just make another one of these, and this time we call it process octaves add. And we're using that instead. Also, we have to adjust our process width method, because at the moment process width just calls process octaves, or alternatively we are taking process octaves out of here and instead putting it here, so that we don't have to have so many additional functions. That means that we also have to do that in the original method. So we also need a different method for process width, since it also synthesizes samples. And if we look at process width, then we see that it does so in two different ways. One of them is that we are currently not smoothing and the width is set to 0, which means that we're just copying from the left to the right channel because it's the same signal. And then it also synthesizes on process octaves. So now let's just copy this method and also give it an add version. And in the add version, we are adding. Okay, now we actually have a little bit of a problem, if you notice. Because let's say that we're currently on the adding Perlin noise synthesizer. That would mean that in the left channel we already have the input from the first Perlin noise synthesizer and the second one. Now if we copy that to the right side, then we have already copied that in the first Perlin noise synthesizer. So this just makes entirely no sense. I would have to restructure everything to get this to work like this with add functions. So my new approach is to just get rid of these functions again and get rid of this method again as well. Just going back to what I had before. And even though it seems clunky, we cannot optimize like that for now. Instead, we will do what is easy and just make an audio buffer, and this is going to be the temp buffer, because it will be used for these temporary moments. In prepare, we now have to set the size of the temp buffer to 2 channels and block size. At least that will give us an easier time understanding what the code is doing. Okay, so GitHub Copilot already suggests some stuff. I think let's just look at that for now. I wanted to start with if crossfading as well. So if we are currently crossfading, then to the phase is being added 1 divided by num samples. I don't know what that should be, but I think GitHub Copilot was just weird because we haven't added any value here yet for the increment value of the phase, obviously. So it makes sense that it just didn't know what to do here. For the increment value, we will just come up with a little something. Let's just say, yeah, 1 divided by sample rate, which is 1 second. So now every transition should just take 1 second. Get right pointer. I don't think any of this makes sense. It's just a weird way of describing what should happen. Let's remove that again. What I actually want to happen is I want to get the samples from the temp buffer. Temp samples is temp buffer get array of right pointers, so that I can call the other Perlin noise object with these samples. And as you can see, that immediately gave me something that makes much more sense. However, I want to use num channels and not 2, because it might be that this is a mono track. Always have to check what GitHub Copilot suggests to you, and then it's cool. What have we written? We have a Perlin noise object that processes with a new tempo sync rate, and we have a Perlin noise object that processes with the old tempo sync rate, and the new one is processed onto the samples and the old one is processed onto temp samples. Phase is monophonic, but we want to use stereo channels. So it would make sense to actually make a phase buffer, and this can be float again, because when we have already calculated the phase, we can just truncate it to float, I think, and it will be approximately correctly. So the phase buffer will just be block size. So now we can synthesize the phase buffer by looping the block and then saying phase buffer as is the phase moves on. And then if phase has reached or exceeded 1, then first of all that means we don't want to crossfade again, and this will trigger the next block when it comes to the question if we're still crossfading or not. We don't want to crossfade anymore then. It would make sense to just set the phase to 1, because that would mean even though we are still putting stuff into the phase buffer, it will just keep on being 1. Actually only trigger it if it exceeds 1, because 1 is still alright. And now we can actually transition the information for each channel. We now have the original samples and we have the temp samples. We only need the const temp samples at this point because we're not altering them anymore. Looping through the samples, and now samples of s equals temp samples, because temp samples is the old buffer, the last Perlin noise modulator that we used, so it's the one that we are starting from, plus phase buffer of s. Now you see why I used float for that, because we are also dealing with float values on the temp samples, so that it just is being matched. Phase buffer s, why does it not like that? So this copies the stuff over. Okay, now if I'm not mistaken, and this should already be the logic. Okay, it didn't like this for some reason. Do I still have to do this or what? I thought that I made a type def for this. If not, then I will do that now. Okay, now that should be the thing that works. Let's see. Alright, so now we have the situation that we had before, where there is just modulation going on, and we just want to avoid discontinuities from the loop now. So I will just make the loop a lot bigger, so that we can test the state. Okay. It does not look continuous to me, because actually it should look a little bit more like this when changing the rate. This is now the non-tempo sync rate. And as you can see, changing it looks smooth, and I want to get a similar impression from changing it on the tempo sync mode. But at least it works to just end up on the new rate. So this is the half bar rate. You can see that it's always a half bar to get to the next point. And this is the 16th. So it kind of does the right thing, but it just doesn't transition in the correct way. It did copy the file, so this is definitely the new plugin. It just for some reason still doesn't do the correct thing. So what can we learn from this? Let's imagine we have a rate change now. Will it ever catch this state? Rate beats is not input of rate beats. It should do that because rate beats starts at -1. So the first time this method hits, this is true. But why does it not work? Is the transition too fast or what? But 1 divided by sample rate is... I mean, it's a whole second. It shouldn't be too fast. Let's make it a bit more drastic and say 10 seconds. Maybe we will see some characteristic then that makes the issue pop up. That's one way of solving this problem without actually having to go line by line through the code. You know, just thinking practically here. We have already accomplished a lot by just making this whole class that is about to work. And now someone is probably already screaming at the screen because they see whatever my issue is here. So okay, now transition. Transition is hard. But why? I have an idea how I can make it a bit more visible. I want to put the door to the side a little bit so that I can use the console. First of all, I want to find out if everything works correctly about the phase. And in order to do that, I will just put a debug for the phase. And as long as I'm not doing that for every single sample, it should perform just fine in process block, even though people always say don't put a debug into any process block type of method, but it works if you are not doing it too much, as you will see. So now this will give us multiple types of information, I think. First of all, it will give us the information if the phase works correctly at all, and also if it goes on doing something when it should not be crossfading anymore, which are both very vital informations. Okay, so the debugging starts, and we can see there is no console output. So as long as the rate is not actively changed, it will not perform any crossfading. And then it suddenly performs and it's way too fast. Like, what type of speed is that? And that explains perfectly why the discontinuity is so sharp here. When it's always transitioning so fast, you cannot really expect it to be smooth. So I was apparently wrong about this being 10 seconds. Question is why? I think I went into the wrong direction when I put it to 10. Maybe I should have put it to 0.1 divided by sample rate in order to get it to 10 seconds. Sometimes I mix that up. But that's also a great example of why you don't need too much math knowledge for these kind of things. You just need math intuition, because you might make mistakes like this, but then you see that you were wrong, so you can just address it. And now that would be a much better candidate for a good phase speed as well. So we can just do the same test we did before again. Alright, so now we expect this to be actually 10 seconds. And it already does something, and it does look like it takes 10 seconds. Now let's transition somewhere else. Okay, there was a discontinuity right at the start. And now we want to just type in a value instead of dragging the knob. So we can see how it snaps without, you know, the natural smoothing of moving a knob. And let's go. Okay, we can see there is a direct transition to the next rate. It doesn't seem like it is actually crossfading anything, even though we see the phase going on here. So we can safely say the phase values work correctly, and the fact that it only does the crossfading at the right moments also works correctly. We can put this back to 1 second, which is probably way too much already, and we can actually start thinking about why it doesn't transition. The only thing that I could imagine why it wouldn't do that is because it actually gives the same parameter values to both Perlin noise objects. So now we have triggered the breakpoint, we can step through it, and we can just check for the first values. Now, the last Perlin noise synthesizer has on the first sample index on this channel minus 0.21, and the current one is minus 0.49. Now, next thing, we have still pretty samey values, and the phase moved on a little bit. So everything looks like it makes sense so far. Let's continue. And now we are in the next block, just looking at some different values now. Okay, these values look exactly the same now, and that's very weird. And it would explain why there is an instantaneous shift. Yeah, I get why. The problem is that the next time we are reaching the set parameters method, it updates both Perlin noise modulators. But in the case that rate beats didn't change, it should in fact only update the Perlin noise modulator that is currently used. That makes a lot of sense, and that should fix the issue now. The way I approach this problem now, I'm trying to explain it. I looked at the values that are produced by the output of the Perlin noise synthesizers, and I noticed that after one block of processing, they were suddenly the same, and that had me skeptical because I would expect them to be different. But the fact that they are the same, that matches what we saw on the oscilloscope, that it just snaps to the new rate. And that makes me think, okay, maybe there is something else that has changed about one of the Perlin synthesizers. So I went back to the set parameters method and found out that if rate beats are not different anymore, the thing that I did was looping over both Perlin noise objects, which obviously doesn't make sense. So now let's run this again, and fingers crossed that it works now. Okay, I'm not sure yet if it works. It looks a bit snappy. Like, what is that? Then let's just try something different. Now we go to 16th notes and we type in a value like 2.5, very far away, and we just try to see if there is anything snappy about that. And we see it's actually really smooth. Maybe this was a bit edgy, but I think it looks okay because it's at least continuous on the curve. Let's try that again, because I have a suspicion what the issue just was. Let's go to 1/8 dotted. Okay, there was kind of a hard transition here, but it still continues, so it's cool. And now let's go to 1/16. Great, so that works. But there is one thing for sure, which is that it doesn't look so smooth when you're moving the knob. Then it can still have discontinuities. And I think that is because of the edge case that I was thinking about earlier, where when the crossfade hasn't reached the end yet, then why would rate beats be updated already? But we can do one very easy fix to that. And currently not crossfading. Just adding that to this. So this should potentially now work, except that it would mean that we are still updating this rate beats with a new value. I don't know, maybe we should just use the same value as this one then. Yeah, that would make sense, because we are only updating that when this condition hits. So the input argument would not do any harm unless we stopped crossfading, I think. Great, that seems to work. It's just a little bit slow. So now we have fixed the edge case where the rate beats changes before crossfade ends. And we also optimized the set parameters call, but just because it was buggy before. So it was not an optimization but a bug fix actually. It can be optimized, like the amount of memory used. Junge! GitHub Copilot moment. Memory used for crossfade, because you know we have a lot of duplicate objects now just for the fact that we have 2 of all of this. So maybe that could be optimized at some point. I will not do that in this video now, because this was just a video about how to approach a new problem in general, not about how to optimize it to the end. And one important way to deal with these kind of things is to just take notes about the things that you want to do in the future. Oh, actually this is solved now, so I can actually put it away. Nice. Okay, memory used for the crossfade could be reduced, and as a to-do feature I think I could just try different methods of crossfading. I'm not sure yet if I want to do that, because at the moment our crossfade is like this. So, you know, one signal fades in, the other fades out. And alternatively, one could imagine that there might be this curve, which is often used for dry-wet, equal loudness type of things. But I'm not sure if it's suitable for this modulator, because we have to make sure that the modulation signal never exceeds -1 and 1. So it might be that this has the potential to cause overshoot. I have to think this through a little bit more though. But it also might cause a more smooth transition. Another way to crossfade could be to use cosine curves or an approximation to those. That could also be a very nice way to crossfade. I don't know. Maybe it would make the transition a little bit smoother, because it starts in such a flat way and also ends in a flat way. So that's definitely worth a try. Cosine methods or equal loudness. Okay, so what did you learn from this video? You learned that if you are just a musician and not a programmer by heart, then you can still build cool constructs in code without having to be too mathy, because you can just look at the problems and think about them. And if you are thinking logically, then you can find a solution. You have a lot of tools at your hand, like setting breakpoints or just looking at your logic, using DBG to look at values at different points of the code. And also you always have to have the ability to rethink your approach. Like that one time when I tried to go into the Perlin object and try to add these add methods for everything, and it didn't work out because some of my written logic just doesn't like that. So I just had to go back from that approach and try a safer approach in some way. And yeah, I'm very happy about that now. I actually don't feel like it looks that messy. Another thing that you probably learned from this video, but kind of on a different note, is that I'm working on this Perlin noise mod. And you know, I already had one in my plugin Nell, but I actually want to replace the one in Nell with this new one, because the old one had some very questionable logic, especially when it comes to the speed of the Perlin noise. It just doesn't make sense what's in the code. That's why I had to write it from scratch. Yeah, and also because of the new feature that I wanted to add, tempo syncable rates. I also want to release this plugin as a plugin in itself, so that especially people who use a DAW that lets you modulate parameters with audio rate input signals, like Bitwig and Reaper, I think, and FL Studio also with a peak controller, I think. I'm not sure. These DAW users can then use the Perlin noise modulator to add a very natural type of random noise to all kinds of stuff. But I will make a separate video about presenting how they can be used musically when it's actually ready. And then I will also add this to Nell and re-release Nell. So it's going to be pretty nice.